Today we're going to continue solving systems of equations. Yesterday we looked at solving systems of equations by graphing. This was our solution. Today we're going to look at solving systems of equations by substitution. So the equations that we're using are x plus 2y is equal to 4 and 2x minus 3y is equal to 1. When you're solving a system by substitution, you need to solve for one variable. Or I should say solve one equation for one variable. So I always say to pick an equation that has the easiest variable to solve for. And for number 2 here, I would say that the first equation, x plus 2y is equal to 4, would be the easiest one to solve for. And specifically, I would solve for x because it is alone. It's not with another number. When I solve for that, I have x plus 2y is equal to 4. Because I am solving for x, I need to subtract 2y from both sides. And that leaves me with the equation of x is equal to negative 2y plus 4. Now that I have this value for x, I know x is equal to 2y plus 4. I can substitute it into the second equation for x. So I know that x is equal to 2y minus 4. Therefore, I substitute it into 2 times x minus 3y equals 1. I substitute it in for x. This becomes 2 times negative 2y plus 4 minus 3 times y is equal to 1. Now I need to solve for y. In order to solve for y, I need to use the distributive method. Distribute your first term to both terms in the second set of parentheses. The first set of parentheses. This will give me 2 times negative 2y, which is negative 4y, 2 times 4, which is positive 8, minus 3y equals 1. Combine like terms when possible. My only like terms are negative 4y and negative 3y. That gives me 8 minus 7y equals 1. Remember, I'm solving for y, so therefore I would have to subtract 8 from both sides. That leaves me with negative 7y equals negative 8 plus 1, which is negative 7. Divide both sides by negative 7. That's going to cancel on both sides. Remember, when you're dividing a number by itself, that's equal to 1. So y is equal to 1. Once we know what our y value is, we want to substitute that back into the original equation. You can pick either equation. I tend to pick the other equation. So pick x plus 2y equals 4 and substitute that back into the equation for y. All right, so I took the first equation, x plus 2y equals 4. I substituted y equals 1 in for y, and now I am going to solve for x. Solving for x would result in x plus 2 is equal to 4, and I would subtract 2 from both sides. X is equal to positive 2. That's my x and y value. When you write your answer for a system of equations, you should write it as an ordered pair. We went over that in yesterday's video. So yesterday's video talked about the point of intersection, which was an ordered pair. Here, we still have an ordered pair. We have our x value of 2, and we have our y value of 1. That's our final answer. You can always check your solution by substituting that back into the original expressions and making sure that it works out. We actually did this problem already, so this is the same problem that we're doing 3 times. If I scroll up to yesterday's, you can see that these are the same equations. So we already checked our work. We already checked this answer of 2, 1, and it already worked out. So far I have solved the same system using graphing and substitution, and it's resulted in the same answer. Lastly, I'm going to solve by elimination. So elimination is when you are adding the 2 functions together and you are eliminating a variable by either adding or subtracting. So when you're solving by elimination, you need to make sure that your coefficients are the number that's in front of a variable. So you need to make sure your coefficients of one of the variables are the same. What I mean by that is we need to be able to either add or subtract and get rid of that variable. What I notice is that this first expression of x plus 2y is equal to 4 does not have a coefficient with x. So I'm going to take that as the easiest one to do, and I'm going to multiply this entire first function by negative 2. The reason why I'm multiplying the entire first function by negative 2 is because the second function has an x value of positive 2. So if we add negative 2 and positive 2, we'll end up with 0. Make sure when you multiply the function, you're multiplying it to all of the terms. Our new function will become negative 2x plus negative 4y, or minus 4y, but I'm going to write it as negative 4y, and that's equal to negative 8. Our second expression stays the same. We did not multiply anything by the second expression. We have 2x minus 3y is equal to 1. Now that we have 2 expressions that both have the same leading coefficient, actually I should say opposites, opposite sign of the leading coefficients, we can add these 2 functions together. If we add negative 2x plus 2x, that's going to give us 0x. That's what we were trying to do, get that to 0. And if we add negative 4y plus negative 3y is negative 7y. And negative 8 plus 1 is negative 7. So just note I added top and bottom together. And that's what gave me my solution. So at this point I have 0x minus 7y, or just negative 7y, is equal to negative 7. I'm solving for y, so I'm going to divide both sides by negative 7. My solution is going to be y equals 1. Once you have your y variable, you do the same thing that we did for substitution, and you substitute that back into one of the original expressions for y. So I'm actually going to do the same one. You know what? Let's do the other one. Let's do the second expression. In the last example for substitution, we did the first expression. So let's substitute y equals 1 into the equation of 2x minus 3y equals 1. When I substitute that in, I have 2x minus 3 times 1 is equal to, is equal to 1. So at this point, I just replaced y equals 1 with 1, or I replaced y with 1. I have 2x minus 3 is equal to 1. Add 3 to both sides. 2x is equal to 4. Divide both sides by 2. And x is equal to 2. So once again, we solved the same set of equations, but we did it in a different way. This is the third method of elimination, and we ended up with the same answer. Our x value is 2, and our y value is 1. You can check it by substituting this back into the original two answers. We already did that. Check back on yesterday's video to see that if you need to. I'm just gonna do a quick reminder off to the side. An ordered pair is a point on the coordinate plane, and an ordered pair is written as x comma y. That's why I'm writing my answers as a set in parentheses. I'm writing my x value first, my y value second. So if we look over here, x value first, y value second. That's called an ordered pair. Looking at the bottom of the page, there's a note that reminds us all three methods yield the same answer, which we already talked about. So we need to talk about what method you should use, or when to use each method. Reading through this statement here, I typed for you, it says, systems of equations don't always have an exact solution. Therefore, the graphing method is not always accurate. If the graphs are not perfect, or the answer does not consist of integers, meaning nice whole numbers such as 1, 2, 3, 4, numbers like that, it is unlikely we will obtain the correct solution from the graph. Algebraic methods are used to find exact solutions of systems of equations. So if you're going to end up with a fractional answer, you absolutely want to use either substitution or elimination. Those are one of your algebraic methods. Again, graphing only works if you end up with nice answers. Lastly, let's talk about what solutions look like. We have one solution if the graph only crosses in one place, which is the only place the graph can cross or the two lines can cross. So one solution is represented by a couple of things. It's represented by slopes that are different, and the lines intersect at one point. If a graph has no solution, which can happen, there's a couple of things to notice. First of all, on a graph, the lines just never intersect. So they're parallel lines. They continue in both directions forever. They never cross each other. So there would be no solution. Also, if you're looking at it algebraically, you know that the slopes are the same. The y-intercepts would be different in this case because they're parallel lines, so you have two different lines. And also there is no intersection of parallel lines. Once again, that leads to no solution. And lastly, infinitely many solutions. That is when you have the exact same line graphed on top of itself. When you have the exact same line graphed on top of itself, algebraically, you have the exact same two equations. But to be specific about it, the slopes are the same, the y-intercepts are the same, and the graphs intersect everywhere because they are the same. You have three choices for solutions. You have one solution, no solution, or infinitely many solutions.